All right. You want to? All right. Go ahead, Jason. So you want to
Yeah.
ask a chem question? Yes,
Yeah.
please.
So in half cells, right?
Half cell, yeah.
Yeah. So when you're finding the which one's the anode and the cathode, right?
Yeah.
The anode is oxidation, right?
Anode is in galvanic cell. Anode, yeah. Anode reduce electrons. So it is oxidation. Yeah.
Yeah.
Yes.
So when you look at an electrochemical series,
Yeah.
would the one being would the one undergoing oxidation be higher or lower than the one
Okay. Let
going
me to explain
reduction?
that one, right?
Okay.
So I need a piece of paper for that. So
Yeah.
maybe how can I get it? Um, but okay, I just share my biology file and I
Okay.
write on that, right?
Okay. Yeah.
All right, this is biology file, but we have surface to write, right? All
Yeah.
right, electro series. Yeah. So electro series, right? So electro
Yeah.
series, you have yeah, in the middle you have copper plus 2 electrons. I think copper
2+. Yeah.
2 plus
Yeah.
and reversible reaction coming from copper, right? Copper solid.
Yeah. Yeah.
And down the track, you have zinc. I think 1 electron there. There's 2 electrons again. If I remember right,
Yeah. Yeah.
zinc 2 plus. All right, plus
Yeah.
here. Now, this is the first galvanized cell made by Galvani somebody, right? So,
Yeah.
so
Yeah. Yeah.
yeah. So he's an amazing guy, right? He was
Yeah.
he was doing that many thousand times with half
Yeah.
cells. So this is
Yeah.
one half cell and this is the other half cell. So anode half cell is a zinc electron in zinc chloride solution. So it has zinc ions, 2 electrons here, right? Zinc ions. So then this is copper sulfate, copper plus ions, right? And then you get copper rod, the copper electrode. So these are the half cells you're talking about, yeah?
Yeah. Yeah.
I think. And once you connect it with the wire, external circuit, this light doesn't light up and then switch off. Just a little bit bulb just light up. And the Galvani was changing the things, everything, A to Z, and he never
Yeah.
sleep, right? Then
Yeah.
he got an idea and he put a salt bridge, put potassium nitrate in there. Okay, this is zinc nitrate, by the way. Minus this is copper sulfate.
Okay.
Copper sulfate is blue color. Zinc nitrate colorless. But what is this?
Do we have to know what colors and stuff they are? Like observations?
Well, there are sometimes what happened to the blue color in copper in cathode
Okay.
half cell. So the
Yeah.
blue color disappears slowly, right?
Yeah.
So that's why I mentioned that. So you can see
Okay.
the reaction. If there's a color in there, so then you can see
Yeah.
the reaction easily. If they're
Yeah.
colorless, you don't know it is happening. Only indicator is this bulb is lighting up, right? So
Okay.
here,
Yeah.
in addition to bulb is lighting up, we can see this the nice blue color is fading off during the
Yeah.
reaction happen, right? So this is what is in
Yeah.
salt bridge? Salt bridge potassium nitrate.
Okay.
And it has a nitrate, okay, K in capital N.
Yeah.
The nitrate
So what
ions and
happens to the potassium?
potassium come to the um, cathode. See, it's come to the cathode chamber, cathode mix because
Yeah.
copper go and deposit on copper electrode. So who replaced the
Okay.
charge? The potassium replaced the charge.
Potassium.
So why
Okay.
potassium? Why not
Yeah.
something else? Because potassium has no game with copper. I'll tell you
Okay.
in a minute, right?
Yeah.
Because why it is? So this question here, right? Or now this is electro series, right?
Yeah.
So okay. So then towards, right, to the bottom. So ability of giving giving up electron is increasing. So giving up electron is what?
Yeah.
Giving up electron is oxidation, right?
Yeah.
So
So when you go down,
when you go down, the power of oxidation, right? So
yeah.
power of oxidation increase because they are strong reducers. So you know that word, there's a word game. So
Yeah.
power
So
of
oxidants get reduced and then reductions gets
yeah,
oxidized, right?
yeah, power of
Okay.
oxidation increase means they are strong
Yeah.
reducers. Strong.
Okay. So when the value, so you know how they each have an value on the chemical
Yeah,
series, right?
yeah, right.
So the more negative the value gets, the stronger it is. Stronger reductant.
The E value is going to be higher when the distance between these two getting higher,
Okay.
right? So for
Okay.
example, now
So
yeah,
so the more negative the value gets, the stronger the reductant it is, right then?
it is not negative. It is nothing to do with
Okay.
negative. So it could be, right? It could be okay. Put it this way, right? So imagine negative start from this line, right?
Yeah.
And then, but that is not the case, right? So
Yeah.
the the strength of E
Yeah.
depending on how much positive this and how much negative this, both together. All right,
Okay, so you just add them together.
add them together. Right?
Okay. Yeah. Yeah.
Yeah, that's what it is. So
Okay.
then reactions happen. The zinc become. I just change the color. Right? Okay, look at my red color arrow. Come this way. The zinc
Yeah.
becomes zinc ions. So zinc becomes zinc ions, come to the solution, and electrons go that way. Right? That is
Okay.
anode. So the
Yeah.
electrons coming down here, and who take the electrons? Copper take the electrons. Copper take the electrons, become solid copper, and solid copper
Yeah.
deposit on here, right? And this reaction go that way.
So the cathode is where there's it gets deposited, and is the anode the one that gets corroded?
Yeah, always anode
Okay.
get corroded, cathode get
Okay.
going. That's Galvano reaction, right? Galvano cell.
Okay.
So
Yeah.
then, so now, did you see that? So then,
Yeah.
so this is the starting material, right? Reaction happen between zinc, because zinc is the one becomes zinc plus, and copper plus is happening the other end. Copper plus become copper. So then you demarcate or you just circle up what is between the reaction between which one is which one. It's not big. It's not between zinc ion and copper solid. No, it is between zinc solid, right? Because
Yeah.
in this anode zinc solid is the one here, and happening
Yeah.
between zinc solid and from here who react? Copper ions react. Copper ions. So we just combine them. So now you can see.
Yeah.
Now you can see the Z inverted Z letter. See this way, that way, this way.
Yeah. Okay.
Right? So this inverted Z letter, this shape is so important, right? So if it, the shape is the other way around, it's not happening. It's have to happen that reaction. So you select the you could just look at the electro series and mark down where the reaction, which one is with which one, and then circled up what is actually which is reacting with. It should be exactly this inverted is a shape. Otherwise, the Galvano cell reaction won't happen.
Right? Oh, so an electrochemical series. So it must be like diagonal.
Yeah,
going
exactly.
Down.
So remember this inverted is a letter. And maybe you can cut and paste that. Yeah.
So that means the oxidant has to be higher than the reductant, and it has to go at a diagonal line, right?
Yeah, the oxidant.
Yeah.
This is actually the oxidant. Yeah, oxidant has to be higher than reductor.
The reductor.
Correct.
Okay. Yep.
Correct.
Yep.
And the
Okay.
higher the difference, then you get better the reaction or more feasible the reaction is. Got it?
Okay. Okay. Yep.
All right. So
Yep.
is that all? So
No, I have another question.
okay.
All
right. It's
there
okay.
was
Erase that one.
Yep. Yep.
Okay.
It was for electrolytic cells, and it was when you so it was for electrolytic cells, and it was when okay, yep. Okay, and for this one, right? It said write the cathode and anode reactions,
Mm-hmm.
and it had two graphite electrodes.
Yeah.
And the mixture was a one molarity, AgNO3, but it was an electrolytic cell. So
Right.
that means the cathode and anode swap, right?
Okay. What is inside the here?
The mixture of AgNO3.
Silver nitrate.
Silver nitrate, yeah.
All right. So look, this electrolytic cell, and because of that, it is connected to an external power supply.
Yeah.
Right?
So that means that in this one, yeah, the anode is positive, right?
Yeah, anode here, because anode is the one that is positive electrode of the power supply. This is negative electrode of the power supply. So then,
Yeah. Okay.
so actually, which way the electrons go? So this way current goes. See, you focus. But that way electrons go. Electrons go this way.
Yep.
Right? But
yep.
Then it is a kind of a something to do without thinking, right?
Yep.
So positive electrode of the power supply is connected to positive electrode of the battery of the cell, and negative electrode of the power supply connected to negative electrode of the cell, right? So therefore electron go to this one. And other thing you have to remember, electrons go this way, right? So who carry the electron, which electrode, this electrode is the one carry the electrons into the solution. And because it carry the electron into the solution, because of the same reason, right? Remember the reason? We call it cathode. We call it cathode.
Okay.
It is no difference between electrolytic cell and galvano cells. Any electrode taking the electrons into the solution, that is cathode.
Yeah. Okay.
So obviously the other one is anode, right? You recognize cathode first, and then obviously the other one is anode. So then, so then, who carries? So there are two different kinds of ions here: the cations and anions. So what are the cations? Which the ions go to cathode? What are the anions?
But so the cathode would be silver, right?
The cathode is okay. This is both carbon, right? You say carbon. Graphite means carbon.
No, graphite. Yeah.
This is carbon. Right? So then, none of the electrode is silver, right? But the electrons, the graphite transmit electrons to the solution, but graphite do not participate any reaction. Platinum is the same. Platinum or graphite, they don't participate in the reaction like the zinc electrode corrode. On these ones not corroding, right? None of them. So instead, they transfer the electrons into the solution, and there is because it's cathode carrying the electrons, cations are the ones taking the electrons. So who is qualified for cations? Who are the cations? Oh, Ag or
that
NO3?
Would be Ag, right?
Ag, right. So Ag, cathode reaction is therefore Ag. Ag
and
plus.
So I was doing it, right? And so this was in a so I was doing it, and then I figured out that Ag was the cathode.
Yeah.
And then I went to the anode.
Ag is not